Hi, this is part 7 of Cycle Time Reduction Secrets. Mike Boyd's joining me again today. My name is Darren Harville. We're here in our Experience Center, standing in front of a digital canvas that we use to collaborate with customers and communicate with you, to listen to what your issues are so we can help you. And today we're going to continue our conversation, Mike, about non-cut time, how to reduce cycle time. What are we going to see today?
Yeah, again, talking about reducing your machining cycle time and focusing on non-cut time. Today we're going to talk specifically about a parameter change, and yes, there's a parameter for that. You always hear that phrase. We're going to talk about a parameter change in reference to rigid tapping, and we're also going to talk about a Makino feature, and this Makino feature is called GI, or Geometric Intelligence Drilling. So talking about the rigid tap parameter change, that's FANUC or FANUC parameter 5211, and that is for the retraction of your tap after you tap the hole and it's coming out. And you can control the percentage of feed coming out of that hole. And this is a standard FANUC parameter. Now, this is not a Makino specific parameter. So this should be applicable to any of your FANUC-based controls. So if you change that to 200, meaning 200%, then that tap's going to retract 200% of your feed going in. And it could potentially save seconds across a number of holes, could really add up too.
Now, Mike, I know whenever you talk about some of these features, I've heard you say to people, hey, you need to check the part, check your work. You're talking about rigid tap retract. You want to make sure you get a good thread. I assume it's a good thing to remind everyone you need to check to make sure you're getting the quality part you want.
Yeah, and not just this change or this optimization, but any change to your cycle at all, you need to verify that quality first and foremost. So the next thing we're going to talk about here and show you is our GI drilling. Now, this advanced motion control feature on a Makino is a Makino feature only. And what it does, it takes your rapid motion, again, non-cut time, from hole to hole and truncates that motion. Now, typically, it's a very linear move. You retract in Z, you move X, Y, or X and Y to the next hole, and then you're back in Z. Well, this GI drilling takes that path, truncates it, smooths it out into an arc. Now, it does a couple of things. Obviously, it reduces your cycle time, but also gives you smooth motion from hole to hole. So over the life of your equipment, that could help to improve the life over time, that smooth motion. So again, this is a Makino specific feature that we're going to show, and I'm going to show you how you can save cycle time using this feature.
Mike, I know a lot of our customers tap a lot of holes, so I can see where that's going to be a big difference for people if they can speed up the retract. That can save a lot of time when you're tapping a lot of holes. We're going to see that on a machine out on the floor. We've got an 851NX set up. We're also going to see this GI drilling feature as well. So I'm anxious to see it. I'm sure our audience is. Let's go see it.
Yeah, let's go. So this next demonstration, I'm going to show you how a parameter change, yes, there's a parameter for that, can reduce your cycle time in your rigid tapping cycle. That parameter is FANUC or FANUC 5211. And what that parameter changes is the retraction of your tap. So I'm going to show you at 100% default and then 200% retraction and show you that cycle time savings. The next demonstration after that will be your GI drilling demonstration. And I'm first going to show you drilling 10 holes using traditional linear motion type retraction and positioning. And then next we'll turn on GI drilling, and I'll show you the truncated motion from hole to hole that really smooths that out and improves your cycle time. So let's get to it. So the first one, a rigid tap retraction. Start the cycle here. 10 or a couple of holes here, we're going to tap and retract at 100%. Now, after we tap these holes, we're going to implement then changing the parameter, FANUC 5211 to tap extraction at 200%. And we're going to do that right in the program using the G10 programming. So here's that 200% retraction. And you can even hear the difference. as it comes out 200% than what it was coming in. We're recording that cycle time savings and the cycle time for each and macro variables. Let's take a look at this macro variable now. Rigid tap, the first one, 7:18. That's at retraction 100%. You're at 19.5 seconds. And then we recorded 7:19, the time with the 200% tap extraction, and that's at 16 seconds. So quite a bit of savings. And if you're tapping a lot of holes in your cycle, you're going to really implement and get that savings in that cycle time, especially over the course of your production run. So that 200% FANUC or FANUC parameter change, 200% retraction is going to get you where you need to be. So let's look at our next demonstration here. We'll queue up the program, and this is GI drilling. Now GI drilling, the first cycle, this is 10 holes. Again, standard, traditional, linear motion from hole to hole, no GI drilling. Then through programming, writing a program, we're going to enable GI drilling, and we're going to show you from hole to hole that truncated movement, that smooth motion from hole to hole that's going to save you cycle time. Let's get to it. The tool change in the drill. We're going to come over, and again, simulating drilling 10 holes. And what you'll notice from each hole is a straight Z out, and then an XY move, and straight Z in. And this, again, is without GI drilling enabled. To get to the last hole, we're going to move over to the tool change position. We recorded the time. Now this next cycle, exact same hole pattern, but implementing now the GI drilling. And look at that smooth motion from hole to hole, slightly truncated. That's going to reduce your cycle time. And as I mentioned earlier, it's easier on the machine for longevity. We're going to record that cycle time, and let's take a look to see what we have from both of those. From the GI drilling, no GI drilling enabled, the first one is 7:20, that's at 22 seconds. And then with GI drilling enabled, we're at 21.7 seconds. So again, with both the rigid tapping retraction and the GI drilling, easy to implement. You implement these things in your cycle, and over time, tapping, drilling multiple holes, you're going to realize a lot of cycle time savings.
Thanks, Mike. I really enjoy there's a parameter for that. Thanks for showing those to us. And if you'd like to ask us any questions, we're going to be happy to hear from you and try to answer those. Go to the top right corner. You're going to see Q&A listed there. Go down to the bottom. You can type in your question, and we're going to do our best to answer it. Okay, hi everybody. Thanks for joining us. And Mike, again, appreciate you spending time. We're going to be able to answer some additional questions and get into a little bit more information about those topics in that demo you showed. So thanks everyone for sticking around. So Mike, I also want to remind everybody, your handouts, if you look up in the top right, you can see handouts listed there. And the slides that Mike you showed, those are available there. So those can be downloaded. And also there's another handout, some information on the A51NX and the A61NX. There's a brochure there. In the middle of that brochure, there's some information about GI drilling and of course, other great information about that machine platform. So feel free to download that. Mike, our first question that we're gonna take today, you talked about FANUC parameter 5211, and that's a way to go in and make that change that you talked about, where you can speed up the retract. But how do you make that change? Where's parameter 5211? How do you change it?
Well, like you said, Darren, I mean, it's a FANUC parameter. So you have to go to your FANUC side of the control, go to your parameters, turn your parameter right enable on, and find 5211. And 5211 is the rigid tap retract percentage. It's anywhere from 0 to 200. So 200 is the max retract percentage that you can come out of a tapped hole. So that's where you find it. It's over on the FANUC side of your control.
Okay, great pointing that out. And a couple other questions that are coming in here. A question from Michael. He's asking, are these functions field retrofittable? Do they exist on the Pro 5 and the Pro 6 control? So of course we have legacy machines that have Pro 5 controls. Newer machines over the last several years have been with the Pro 6 control. So he's wanting to know about that.
Well, talking specifically about the tap retract speed, again, that's a FANUC feature on the FANUC side of your control. So as far as I can remember back to Pro 3 days, that is available standard on the FANUC side of your control. You can change that tap retract speed. So it's not specific to, just Pro 5 or Pro 6. But when you're talking about GI drilling now, GI drilling is for the current version, the Pro 6 NX horizontal production machining centers, including the A40. So that's what GI drilling is available on. And no, it's not field retrofittable. It's a standard feature on your Pro 6 for your NX machines and A40.
Okay, and as you think about trying to improve your throughput when you're tapping holes, one of the things that is important, obviously, is you don't want to be destroying taps and breaking taps. So there's a question here asking about how do our application engineers go about determining the upper limit for feeds and speeds for rigid tapping so that you don't end up with a bunch of broken taps?
So obviously you start with what material you're tapping and what material is the tap. It starts there with your surface footage for that particular tap, and you calculate the RPM based off of those inputs. One thing I do want to point out is rigid tapping RPM, there's a limit to that on each different machine platform. For example, on the A51, I believe the max rigid tap with the standard spindle is 2,800 RPM. With the 20K spindle, it's 4,400 RPM. So based on your RPM and your pitch size, and you calculate your feed, and that's your max tapping feed. Now that is also the max retract. So if you're tapping at the max RPM going in, and regardless of what is set in 5211, you can only go out the max that the machine will rigid tap. So if you're at 2,800 RPM going in, and that's the fastest RPM you'll be able to achieve coming out. You will not be able to come out 200% then.
So understanding how to enable that feature, as you said, that's a FANUC feature. The GI drilling you talked about is specific to Makino. Greg asked a question about how to enable GI drilling. So can you explain that? What's required to take advantage of GI drilling?
So GI drilling, there's a couple conditions have to be met. One of them, you have to tell the machine that it's a drill, the particular tool in your tool data screen under the kind column, you have to tell it's a drill. Once you do that, then you either simply turn it on through your function screen, or there's an IMP code, it's M1145S2 in your program, enables that. And then M1144 disables, turns it off. So those are the basic conditions that have to be met. There's some other parameters that are detailed in the GI drilling manual that you can set your machine, you configure your machine a couple of different ways, but in general, you have to definitely tell the machine that it's a drill so it knows, and do that in the tool data screen.
Okay, and when you were doing the demo, Mike, for the rigid tap retract, you talked about using G10 in your program, and in that demo you had G10 in there, and you were using that to change that parameter 5211. Can you describe a little bit more about that? How does the G10 programming work?
G10 is a FANUC G code. It's a standard G code. It enables you to write to certain parts of the control. You can write to work offsets, You can write to two offsets. Now on the FANUC side, write to two offsets. You can write parameters. So you can change parameters on the fly, and you do that right in your CNC program. In this example, I use G10L52, and then the format after that is the N or November, the parameter number 5211, and then R or Romeo is the percentage. So R100 in that line would set that 5211 to 100%. R200 sets it at 200%. So that's simply what I did in the program that you saw in the demo. It's right in the CNC program. You can change certain parts of your control, and that's what I did.
And you mentioned the 200%, and that's what you demonstrated for us. Why 200%? Is that the only value that can be changed to? Is that the best value? Can you go even faster?
Yeah, what's interesting is in the parameter manual, it says the values can be anywhere from 0 to 200. So I started thinking about 0. If 0 is in there, would it not retract? I have not tested anything less than 100%. So I assume that you can slow your retract. And I can think of a condition or an application where maybe you have problems tearing threads on the retract. Certain materials might be prone to that. You might be able to slow that retract down using this parameter. Like I said, though, I have not tested a 0 or anything less than 100%. But if the value can be in there, and maybe you can do that.
And when you're thinking about the type of thread that you're trying to manufacture, there's obviously a couple different ways you can do that. There's cutting the threads and there's rolling the threads. And the question here is asking about that. Does this work with both of those types of processes? And Mike, just to make sure everyone understands what we're talking about, maybe a quick explanation on cut and roll threads, and an answer to that would be great.
Yeah, so it's all about how you create your thread. You're either cutting the thread with the tap, or you're going to form the thread with a different type of roll form tap, they call it. And that takes two different tap drill sizes based on what tap you have. The roll form does just that. It displaces material into the cutter, into the form of the thread to form the pitch that you need. And retract, it doesn't matter what type of tap is in the spindle. You can change that retract speed just the same way, whichever tap you're using.
And with the GI drilling, one of the things that we mentioned in our discussion was you need to check your work, check the quality of your work. And of course, when you're GI drilling, you want to make sure that also you don't have a situation where you might run into something, right? Because you're changing that path. You're, as you said, truncating or shortening that path. So you want to make sure there's not something in the way. Is there a possibility for a collision, or how do you prevent that when you're using GI drilling?
Yeah, of course. If you've got clamps that are close to your holes, in between your holes, things like that, or another part feature that's there, yeah, you certainly have to watch for that. You can go in and you can kind of put a Z external offset in and go through and prove out, look at your motion as you're going around the clamps to see if you're going to clear or not. So yeah, it's certainly a concern. So you have to be aware of that.
Thanks, Mike. And as we're wrapping up here, I want to remind everybody this is part 7, as you can tell from the title, which obviously means there's parts 1 through 6. So if you haven't watched parts 1 through 6, Mike, you share a lot of great tips and do demonstrations in those. I want to make sure everyone knows how to find those. You can go to makino.com, go up the top, look for resources, and then you can find on-demand webinars. So you can find those there, parts 1 through 6. Also, you could go to the YouTube channel that Makino has, and they're all there for you to watch as well. And of course, there's lots of other great content. So make sure you take a look at that and see what might interest you there.
And Darren, I want to point out just to get some more information on your Makino about GI drilling. It may not be as intuitive as looking for the GI drilling manual. It's actually on your machine, your on-machine manuals. And the name of the manual is GI Super GI Control. That's the name of the manual. So It's not super intuitive looking specifically for GI drilling. There's a lot more information in that manual, but that is certainly where you find the GI drilling details.
Thanks for pointing that out, Mike. And I also want to thank all of you for joining us. Hope you learned something today. And if you need some more information, please reach out to us. And if you want to have a one-on-one conversation with one of our subject matter experts, also reach out to either your local salesman or Makino.com. You can contact us there. We'd love to hear about what challenges and issues you're facing and how we can partner together to help you. So have a great day and thank you.
Thank you.